So in the last video, we talked about two types and two examples of writing an equation of a line. In this video, we're going to talk about type 3 and type 4, which basically I'm going to talk about two more examples. So let us start with type 3. For type 3, we have a line passes through point -5 and 2 with slope which is 3/5. So this is the information that is already provided to us. Based on this information, we want to write an equation of a line. Again, you can start with number 1 or number 2, but let us ask ourselves which one would be an easier or quicker way of actually writing the equation of a line. In this given information, we have the slope. So let us look at the solution here. So what is given? We have the slope m, which is 3/5. And then the other thing that we know is the point. So this is slightly different than the other two examples or other two types that we learned in the previous video. In the previous videos, we had either the y-intercept or we had y-intercept for both the equation, both the lines. So we were able to use number 1 quickly and write the equation. In this case, we don't have the y-intercept, because keep in mind, y-intercept is the point for which the x value is 0. So here x value is not 0, so we cannot think of this as a y-intercept. It's any point on the line, but it's not the y-intercept. So since we don't know the y-intercept, it is easier, convenient to actually use the second one, which is the point slope form. So using the second one, you can think of this as point x1 and y1. So as soon as you label this as x1 and y1, we can quickly use second one to actually write the equation of this line. Again, first I'm going to write the general form, which is y minus y1 equals to m x minus x1. I'm basically just rewriting the general form for a point slope form. And now I'm going to go ahead and substitute the values. So you can already see, like, once I have the general form in front of me, it's so easy, and given pieces of information, it's so easy to just substitute and get the final answer. So it's going to look like this: y minus y1. I go back and see what is my y1. It's 2. Okay, so I'm going to write 2 here. Then the slope m is 3/5, which is already known, which is already provided to us. And then x minus x1. Again, x1 is -5. Well, whenever you are working with negative numbers, make sure you put them in parentheses. They have to be treated with respect. So moving on, so it's y minus 2 equals to, we can kind of simplify a little bit. So it's x, two negatives, negative times negative becomes positive. So this is going to be my equation of this line through this point and with this slope. Here it is expressed in a point slope form. So if in here it does not basically tell me to write it in the slope intercept or the point slope. So I'm free to write in any way I like. So here I'm going to write it in the point slope form. Now if you want to actually simplify this, let's say it says converted, or we want the final equation in a slope intercept form. So I'm going to also show you how to actually convert it or simplify it so that it looks like the slope intercept form. So what we can do here is, guys, you don't have to simplify further unless it says that it wants you to write the final form in a slope intercept form. If it just says give me an equation of a line, this is good enough. You're done here. But if it says converted, or we want the final form in a slope intercept form, then let's go ahead and simplify. So how can we simplify? It's pretty easy. You have 3/5 outside this parentheses. So obviously, what would you like to do? You would like to distribute the 3/5 with both these terms and then see how we can simplify this. So I'm going to write y minus 2. Nothing changes on the left hand side yet, so we're going to distribute this 3/5. So 3/5 times x is just 3/5 x. And then this plus 3/5 times 5. So 3/5 times 5. What's going to happen to the 5s? The 5 upstairs and downstairs is going to cross out. As soon as it crosses out, you're only left with 3. That's how you simplify the right hand side. Once this is simplified, we still need to do maybe 1 or 2 more steps so that this looks like a slope intercept form. Because what is unique about the slope intercept form? There's only y on the left hand side. So in order to get that y by itself, what would you like to do? Obviously you would like to get rid of this -2, and we already know how to get rid of that -2. We add 2 to both sides. And if you had guessed that, you were right. So -2 and +2 crosses out. I'm left with y on the left hand side, and on the right hand side 3/5 x stays, and 3 plus 2 is 5. This would be my equation of the line in the slope intercept form, and this would be my equation of a line in the point slope form. So once you have it in the point slope form, you can always transfer it or transform it into slope intercept form. Good. That's type 3. Let's move on to the last type, which is type number 4. Let's go ahead and do the type number 4. So type 4, and again, I'm going to use an example. So for type 4, we have 2 points that are already provided to us, and using those 2 points, we want to write an equation of a line. So the 2 points that I have here is 3 and 2, and my other point on the line is 5 and 8. Guys, we should also visualize these things. As we are doing the math, we should also try to visualize these things. So this is basically, you're thinking about a line, and on this line there are 2 points. I mean, there's so many points on the line, but we need 2 points, at least 2 points, to actually be able to write an equation of a line. So in this case, the 2 points that are already provided to us is 3 and 2 and 5 and 8. Okay. Sometimes if those points are not provided to you and you only see a line, it is your job as a student to identify those 2 points, and you can identify any 2 points as per your convenience and then write the equation of a line. Okay. So let's go ahead and try to write the equation of a line in this case. So in this type 4, this is the one I like to do all the way at the end, because it requires more steps and more work. Because the first thing that you see here is the points are given. We need the slope, we need points, or we need y-intercept to write an equation of a line. In this case, we have points or a point, but we don't have a slope, we don't have a y-intercept. So first, let us go ahead and try to find the slope, because if you look at both of these forms, in both of these forms we need to know the slope, right? So the first thing that we should do in this case is to find the slope. So let's go ahead and find the slope. Again, I would like to identify this as, or label this as x1, y1, and obviously this would be my x2, y2. So let's go ahead and find the slope. We already talked about the formula to find the slope. Slope is change in y over change in x, so I always like to write that first, y2 minus y1 over x2 minus x1. And now I'm going to substitute the values and find the slope. So y2 is 8 minus 2 over 5 minus 3. 8 minus 2 is 6 over 2, which is 3. The slope is 3. We have the slope. Now, we can take 2 routes here. One is, we have the slope, and we can go ahead and actually find the y-intercept. Once we have the y-intercept, then obviously we're going to use the first way, or the slope-intercept form, to express the equation of a line. Or the other way, which seems to be quicker, convenient in this case, is to use the point-slope form, because we have the slope and we have the point. It does not matter, guys, whether you use this point or this point, because as long as both these points are on the line, you can use any point you like. Okay. So let's go ahead and use the point-slope form. Y minus y1 equals to m x minus x1. So it's y minus, I can use this point or I can use this point. It does not really matter. So let us go ahead and let's use the second point instead of the first point. If you use the first point, and you should do that as an exercise, if you use the first point, your final answer would be still the same. Okay. So y minus y1, which in this case is 8. So then you can think of this as y minus y2 and x minus x2. And the slope is 3, and then x minus 5. The only important thing is that you have to be consistent. I have seen sometimes students make mistake in the sense that they may use 8 for the y, and then they may use 3 for the x. Guys, we cannot do that. You have to be consistent. If you choose 8, then you have to choose the corresponding x value. Guys, if you decide to use 2, then you have to use the corresponding 3 value for x. Okay, so in this case we used the second point, 5 and 8. When y is 8, x is 5. So you can leave it like this. This is totally fine if you want to leave it in a point slope form. But if you want to transform this, or you want this in a slope intercept form, again, it's not a big deal. You already know what to do. You just simply distribute this 3 and then kind of simplify a little bit. So let's go ahead and actually do that. So y minus 8 is 3x minus 3 times 5 is 15. Again, if we want to actually have it in a slope intercept form, we want to solve this for just simply y. In order to get y by itself, we have to add 8 to both sides. We add 8 to both sides. 8's cross out, so we have y equals to 3x minus 7. This is the slope intercept form. Slope intercept form. I'm using SI, and this is the point slope. Point slope form. So guys, this completes type 3 and type 4. We already talked about type 1, type 2, type 3, type 4. In the next video, I'm going to talk about some special cases where we have parallel lines and we have perpendicular lines. Those are 2 important and 2 special cases. But basically the method of writing an equation line is going to be the same that we have been seeing in these 4 examples. Okay, so wait till next time we are going to talk about the parallel and perpendicular lines.